And now basically correlation is a statistical method that tells you how two variables move together. Basically, one variable can predict the other is what you want to see. So instead of independent and dependent variables, we have predictor and criterion variables. We're interested in how knowing one variable can give you some information about the second one. So for example, if I know your height, how tall you are, I can make a pretty good guess about how heavy you weigh. There's just like a relationship between these two variables. And so as a statistical outcome, it gives you a Pearson's correlation, which goes from -1 all the way to +1, and anything in between. It can't go beyond these things. And I'll tell you what this means. When there's a negative correlation, it means one thing, and a positive correlation means another. So let's look at this next graph. When there's a positive correlation, it means that these two variables are positively related. When one variable goes up, the other variable also goes up, right? They go together. When one variable goes down, the other variable also goes down. The example I gave you is height and weight. Usually the taller you are, the more heavier you are to weigh. So in this graph, what we see is that we have an x-axis marking, say, height. Excuse me. The y-axis is weight. And so you could just mark people's down if they're really tall and how heavy they weigh. So this person here would be pretty tall and weigh a lot. This person here is pretty short and doesn't weigh much. And you see, as you plot the graph, a line emerges from here to here. It points that way. And that's the kind of the hallmark of a positive correlation. As one variable goes up, the other goes up, and same thing as if one goes down. The other example I have for you is age and the number of books that you've probably read. So the older you get, the more books you probably will read. If you're very young, you haven't read very much books. So what you see is a positive correlation. One goes up, the other goes up. You could see that there's a, what's a good one about a positive correlation that goes down? Let's say the number of jobs a country has and unemployment rate. Does that go up? No, actually that's the opposite relationship. As the jobs go up, the unemployment goes down, which is the next one we talk about, which is negative correlation. In this case, as one variable goes up, the other goes down. They have an opposite relationship. You can see this. One goes up, the other goes down. The example here I have is the number of street lamps and crime. So if you plot the number of street lamps on this axis, street lamps, and the other one is crime, you can plot the number of assaults and such. You'll find that if you plot this one, that means in this street there's a lot of street lamps and there's very low crime. This street here, this one has very few street lamps but a lot of crime. There's a negative correlation. And you could see that it goes down that way. That's a negative correlation. And so the more it fits this line, this perpendicular line, at a 45-degree angle, the more it is -1. If it goes all the way to -1, that means you have a perfectly negative correlation. So you could predict with absolute accuracy knowing one or the other. Unfortunately, life is never that tidy. So in real life, if you want to look at data that is this perfectly correlated, it's very rare. What you see usually is something in the middle, very kind of weak correlation. That means knowing one gives you a pretty reasonable kind of estimation of what the other one would be. So let's watch another example of this. How about a country's GDP, gross domestic product, and the number of divorces? And these are that's negatively correlated. As the country's GDP goes up, the number of divorces go down actually. And so this is the negative correlation. And it works the other way around too. So as the GDP goes down, there's a depression, the economy is not doing so well, the number of divorces actually go up, right? So that's basically what a correlation looks like. I want to show you before I go what a zero correlation looks like. Here it is. So when two variables are not related at all, that's a zero correlation. It's right in the middle. Again, positive correlation, zero, negative. When there's zero correlation at all, that means if you plot the two variables, that the dots become like this cloud of numbers, and there's no really any direction to it. It's just like a random cloud of numbers. That means as one variable changes, it's impossible to predict how the other will change also. So these are just two variables that are completely unrelated to each other.